In remote and rural communities, water is life. But access to clean water is a luxury. 80% of wastewater goes untreated, contaminating rivers, soil, and drinking sources. Without reliable wastewater treatment systems, millions face disease and environmental collapse. Traditional systems fail here. Too expensive, too complex, and impossible to maintain. The future demands a new solution. A sustainable, smart system built for these communities. Despite its widespread use in rural areas, the existing wastewater treatment system faces several key challenges. Outdated infrastructure remains a major issue as many rural communities still rely on traditional methods. Poor sludge management can lead to long-term complications affecting both efficiency and public health. The environmental impact is also significant, posing risks to local ecosystems and biodiversity. Most critically, the high risk of water contamination remains a serious concern, threatening both community well-being and water security.
In the heart of Malaysia's rural communities, water is life. It nourishes families, sustains agriculture, and supports livelihoods. But behind these necessities lies a growing crisis. Over 7.5 million people in rural Malaysia depend on local water sources. Yet, outdated wastewater treatment systems continue to contaminate these vital waterways. For many communities, traditional septic tanks are the only solution. But Malaysia's diverse geography poses unique challenges, making this system ineffective. In Dataran Pantai Timur, heavy monsoon rains lead to frequent flooding, causing septic tanks to overflow and contaminate water sources. In Dataran Johor, high groundwater level and peatlands make wastewater disposal difficult, leading to long-term environmental damage. Meanwhile, Delta Rajang, with its vast swampy terrain, struggles with poor soil drainage, making conventional septic system ineffective.
To effectively treat wastewater in rural Malaysia, we have designed a multi-stage treatment system that ensures a maximum efficiency while remaining cost-effective and sustainable. The process begins with screening, where large debris such as plastic, leaf, and solid waste are removed to prevent clogging in the later stages. For low-density rural areas, we use a manual core screen and mechanical bar screen for high-density area. After screening, the wastewater enters a horizontal grid chamber. The component is designed to remove heavy particles like sand and small stones to cause damage to the system. This is to prevent blockage and mechanical wear in the stream stages. Next, the wastewater moves into the laminar clarifier, a sedimentation system that increases the settling surface area without taking up too much space. The inclined split allows suspended solid to settle faster, reducing sludge build-up and improving the efficiency of our treatment process. To further purify the wastewater, we utilize an innovative inclined and rotating multi-soil layering, allowing better gravitational filtration. Additionally, the slow rotation mechanism prevents clogging and enhances the water distribution. For high-density area, we integrate a solar-powered system to optimize the energy efficiency, making it sustainable for long-term pollution. In the final stage, the partially treated water enters the control well, where natural processes such as reed and cattails absorb remaining nutrients and contaminants, while microbial activity in the wetland further break down organic matter. This is not only ensure that the water is fully treated before being released, but also restore the ecosystem and promote biodiversity. For the sludge management, instead of costly mechanical dewatering, we use sludge rain bed, which is suited for Malaysian typical climate and rural setting. Sludge is spread over a sand and gravel filtration bed, and moisture evaporates naturally under the sun. To enhance the drying process and create a valuable byproduct, we incorporate coconut husk as it absorbs excess moisture and process it into the organic fertilizer. Now that we will introduce our 3-phase strategy implementation. Our strategy is designed to be realistic, adaptable, and sustainable considering Malaysia's diverse climate and rural population density. For the first phase, we need to validate the effectiveness of our system through carefully selected pilot project. This phase primarily used as follows: conduct water quality tests and infrastructure assessment before installation, work with local contractors and universities for installation and monitoring, train local technicians, and community members for maintenance and upkeep. For the phase 2, after proving the system effectiveness, we will scale up to additional rural communities while optimizing performance. We will roll out the system in high-density rural village where sanitation demand is the highest, remote indigenous villages that lack access to centralized sewerage, agricultural communities where treated sludge can be repurposed as organic fertilizer. Using insight from phase 1, we will refine our design by adjusting treatment components based on wastewater load and local conditions, improving sludge management efficiency with better composting technique, enhancing remote monitoring to predict maintenance needs. We will establish a maintenance hubs managed by trained local, ensuring long-term system sustainability. The training program will be expanded, creating job opportunity in wastewater management. The final phase aims to establish our system as a nationally recognized wastewater solution for rural Malaysia. To ensure financial sustainability, we will promote a sludge to fertilizer business model for rural farmers, introducing microfinancing for community-based wastewater management cooperative, and then encourage private sector investment in rural sanitation projects. Even after full implementation, our system will evolve through ongoing research collaboration with university and sustainability experts, regular performance monitoring and technological upgrades, expansion into other developing regions with similar wastewater challenges.
Through this phased approach, we are not just introducing a wastewater treatment system, we are creating a sustainable, self-sufficient ecosystem for rural sanitation. Our strategy ensures that every aspect, from technology to funding and policy, is covered, making this solution practical, scalable, and impactful for Malaysia's rural communities. By implementing this plan, we can protect water sources, improve sanitation, and uplift rural livelihoods for generations to come.